if you click into these models and click chat with model, spin up a chat window right here. Let's just kind of like formulate our prompts and responses and show you how we're going to feed this raw data to the LLM. Welcome everybody to Fine Tuning Friday, where we share our learnings from fine-tuning open source models on real-world tasks. We'll walk you through what models work, what models don't work, what data we use to improve performance. And today we're going over a fun task, one that we as engineers probably all use every day, and it's how to build a cursor-like tab code completion model. So if you're familiar with cursor, this is probably your workflow where you're just like hitting tab, making little edits, and then having the LLM predict what you're going to edit next. So we're gonna see kind of how the sausage is made, fine tune our own model to do this. And the end goal is actually to integrate this model into Marimo notebooks, who we are lucky enough to have on the call, and we're both a part of this Llama Meta startup program together. And Meta and Llama are gracious enough to reimburse us for all of the compute that we do for all of this. So that's helping us run all of the experiments. And hopefully Llama comes out on top at the end of this, but it will take a lot of data and training to make that happen. So before we dive too deep in, I just want to give you guys a bit of a sense of the tool that we'll be integrating this into. So with that said, Vincent, I'll let you take over the screen and share a bit about Marimo.
Sure. It looks like I'm able to give myself permission to stream, so I'm going to go ahead and do that. And I think people should be able to see what I'm seeing right now here as well, right? And just to confirm, we should be seeing a fancy chart with a slider on top. Just to check, this is what people can see?
Yep.
Cool. Okay. So what you're looking at here is actually something people can play with live now as well. If you go to molab.marimo.io, this is kind of our Colab. So Google Colab is based on Jupyter Notebooks. We now also have Molab with free compute, by the way. So people can totally play around with that. And this is one of the demo notebooks that's hosted there. What you're looking at here is a widget that I built on top of the World of Warcraft avatar dataset. The funny thing about this dataset is it contains logs of World of Warcraft players from 2007. And if this person was playing, every 10 minutes, there is kind of a cron job running on the World of Warcraft server, and we are logging if you are still playing. That's kind of what this dataset is about. And what you can do is you can do kind of session detection, bot detection. That's kind of a thing you can do. So one curious thing that's really cool about Marimo is that it's pretty easy to make these widgets such that, for example, the blue line over here is the normal, sort of the clean data set if I remove bots, but I can also maybe change the slider up a bit, be a bit more critical about when someone is a bot, and like really remove more bots by doing so, and things just kind of automatically update. It's kind of one of the really cool, interesting things about Marimo. And the way that this works, by the way, is Marimo is this reactive notebook. And the easiest way to kind of explain that phenomenon is just kind of zoom in. I can make these two cells appear. And let's also make one at the bottom. I can do things like A plus B. And just the main interesting thing about Marimo is I'm able to change the variable A in this case, and then Marimo is clever enough to pick up, oh, the variable A is used in the cell below here. If this cell above were to update, that also means that I got to automatically update cells below that. And that's also kind of the magic what you see happen here with the slider. The slider points to a variable. That variable is then updating as I slide around. That in turn updates another cell, and that's how these charts over here update. And this is one of the many things that makes Marimo, a bit more modern. We have a nice reactive environment. But to sort of start pivoting towards the thing that you're going to be working on, we also have these AI tools. So if you go to Molab right now, you get a bunch of free compute, but you also get a bunch of free AI credits. So we have some LLM auto-completion bots under the hood. And kind of the nice thing about our bots is that you can refer to a data frame. So in this case, I can say, look, there's this one data frame that's in memory over here. And we could do something like, what are the, how many unique players are in this data set? And because we are referring to a data frame that exists, we're also able to do a little bit of schema information such that the LLM gets injected like the first few rows of in the prompt. So a lot of that useful data set information is something we can just pass along. And this is nice contextual auto completion. There you go. Answered my question. It's really nice to be able to add context like this. So like these are things that you can do with Marimo. I'm only scratching the surface here. But what I think you folks are working on is that you're also able to have your own model that can do tab completion within the cell. That's the thing that you've been working on right now, right?
Yep, that's right.
So right now, that is something you can already configure. You can configure GitHub Copilot. Codium, I think, is also the Windsurf thing is also something you can configure. But I believe that the main interesting thing here, of course, is well, if we can train our own, we can kind of make bespoke things. So maybe we have one that's like really good at polars, for example, and instead of it just being good at pandas, which is like a common breaking scenario even for OpenAI sometimes. But anyway, that just very quickly, this is what Marimo is. It's basically a more modern version of Jupyter. There's like a way to sort of think about it. And there's lots of other details as well, but this is sufficient for the intro, I suppose.
Yep, that's great.
Very good.
Good
Because now
context.
I'm really curious about like some of the stuff that you folks have been doing. So let's switch.
Let's do it. Let's trade the reins. So I'll take back over and let's talk a bit about the task that you alluded to. And so the reason that we're calling this our tab model is we're modeling it off of cursor. So the
You're not
idea,
sharing your screen right now, I think.
oh shoot. Let me
No,
see.
no, he is. I
Oh, I
see
am.
it.
Why am I not seeing it then? Okay, never mind. I'm gonna figure out a button. Go on. Do go on.
Okay, we got it. Cool. So the reason that we're calling it tab is basically you have one tab to skip to the next edit, and then another tab to accept the edit. And sometimes it's good to take a little step back before you go into fine-tuning models to really understand, the problem that you're solving. And so how this looks within Cursor is, say you have your piece of code and you change this file name to be .parquet instead of .csv. Well, what Cursor does is make an LLM call and try to show you the diff of what it thinks you're about to do given the context of your cell. So in this case, it changes this row to say read parquet instead of read CSV. It also populates the file name within here since we have the file name in a variable above. And in this case, it tries to predict some other things that you might want to do. After you accept the changes, then it tries to predict where the cursor should go next. So this is the next thing that you would see in your UI for cursor. So it says tab to jump here. This might be, you might want to do some more data analysis here. The funny thing while I was doing this example is I skipped there, and then the next edit that it suggested was just to get rid of this AI slop that it generated in the first one. But that is kind of the flow, is you'll have a diff, you accept it. Once you accept it, it puts the cursor in a new place and then does the loop again. So that's kind of the model that we'll be putting together. And to motivate this, we actually do have a model that we've trained. I'm going to wake it up and we'll be able to do a live demo and see all of this in action. But we do have some kind of use case specific constraints for the Marimo notebook that we'll be integrating with. And I'm a big fan of open source models for one, and a big fan of being able to run them locally. So our goal here is to train a fast model that you can run on your own machine. So we've been experimenting with 1 billion parameter models, 3 billion parameter. We've gotten up to 8 billion. And so we want this thing, one, for you to be able to download it and just run it in Llama or something like that. But in general, it just has to be fast. It has to be able to keep up with typing. So that's just another motivation for having it be really small. One of the other things is we're just working in the context of Marimo, so it's going to be Python only. So all the training data that we'll be looking at is Python. And then, as we alluded to, we'll be able to optimize it for things like the Polars library or more specific data science-y use cases. And then the final one is this thing must be accurate enough to be useful. And everybody kind of wants to dive directly into fine tuning. And we made this mistake right at the start. We're like, let's just create a data set. Let's start fine tuning. But I would say no matter how confident you are, the chances you prepared the data correctly the first time is pretty low. So if you've joined these fine tuning Fridays in the past, you will know that we kind of have a formula that we'll walk through, which is 1, define your task, which we did above. 2, collect a data set. And the most important one is actually the test data set or the eval data set. So that's where we're going to start. We're going to evaluate a closed source model on the task just to even make sure that our evaluation data set makes sense at all. Then we can get to the fun part of fine tuning the open source model. Then we can evaluate the open source model, and then we can loop back to collecting the data. And quote from Daniel Gonzalez, who is also on the call, who's been doing most of this data prep work today, is getting solid, clean data is a lot of work. Data is everything. It's probably 90% of the the work here. Oxen actually makes it really easy to fine tune models once you have the data. So we'll be spending a lot of time on this section. But first, I want to just kind of vibe with a state-of-the-art model and see how we can formulate the prompts and responses to do this task. So if you don't know, we actually have access to all of the state-of-the-art models right through Oxen. We added Qwen Coder ADB yesterday and Kimi too, so that we could do part of this eval. If you click into these models and click chat with model, we spin up a chat window right here. And let's just kind of like formulate our prompts and responses and show you how we're going to feed this raw data to the LLM. So what we started with is a system prompt here that says, you are a code completion assistant, and your task is to analyze user edits, then rewrite the marked region, taking into account the cursor location. The user intent will sometimes be explicitly given. We'll see it right down here, in which case you must follow this intent. If it's not present, you must infer the intent before implementing the change. So you'll see how this comes into our data collection pipeline later, but the format here is kind of system prompt, an optional user intent, code from the cells above we can kind of put in this part of the prompt, and code from cells below we can put in this part of the prompt. And then we have a small editable region, which at the start will just be the current cell that your cursor is in. And within there, we will tell the model the cursor is here. So this is kind of the input format and the template that we'll be using as we're collecting data and testing these models. You can see here, this Qwen coder model gives a little ramble and then has this Python snippet where it does indeed know the right function from pandas to read a CSV file. Not a crazy example, but this has kind of been my hello world as we've gone along and training these models. Is just like, I want it to autocomplete all of the read and write CSV or Parquet or line delimited JSON, because sometimes I don't remember the exact format for that. So that's the input format that we're going to be working with. The output format that we are going to train the model to do is going to look very similar to the input format, but, and this should just be plain text, but we will train the LLM to first write out what it thinks the user's intent is. So given the code and the prompt that we've shown above, we actually want to train the LLM to first think a little bit before it just starts spitting out the code, and then just respond with the editable region and respond with where the cursor should be next so that we can do that next tab completion. So this is the input format, wherever I had that here, and this is the output format. And I think this guy should be booted up now. So this is one of our small models. We kind of give it a funny name as we're fine tuning, just because we fine tune a lot of these things and aren't sure which one's going to be the one we actually launch. But let's put in a example here. I'm not going to have the user intent. I'm not going to give it any context above or below. And fire this off. Boom. The LLM completed, generate a Python program to read a CSV and create a pandas data frame. It gave us the new editable region, import pandas, had the read CSV, and also did like a print df here, and then put the cursor here. So this is our small model. Yeah.
Out of curiosity, so just I always like to play around with Hello World demos. What could you change the data.csv into a data.jsonl just to see what would happen?
Yes, love it.
Right, so
let's try this one.
just to make sure we're going a little bit further than just Hello World, and we can try polars after, but like always see if like simple little changes like this break it.
Let's do it.
So
I think it needed
mistake.
lines equal true, right?
So this is that encoding thing is, I suppose, fine. The subtle thing here is I think you have to mention that it's a new line delimited JSON. I think there's like a setting for that, if I'm not mistaken. It's forgetting about that one, but okay.
I think I think it's lines equals true in there.
Something like that, yeah.
And so I've actually wired this up if we want to do a more real-time demo here.
Ooh.
Let's like run it in action. So here we have the tab suggestion and the diff, and we can hit tab to accept the changes. So this is kind of like maybe the workflow you might go through. So maybe you change this to Parquet, you wait. The LLM actually, we're putting the responses here, and it hasn't been smart enough yet, the way that we've trained it, to look at the next line and change that. If I delete this, I noticed, okay, cool. Now it knows to complete Parquet. Write this to line delimited JSON. Let's see what it does here. To JSON. Okay, we have lines true here. So
and orient records, that's also true. The closing bracket is missing, but yeah, there you go. Nice.
There we go. Boom. I always forget kind of how to iterate over the rows with an index.
Iter rows, if I'm not mistaken.
I think so. Boom. That looks good. And it's trying to write it to a file in here. So maybe a little too much.
Overdoing it a little bit, I suppose, but
yep. You wanted to try polars too?
Well, yeah. So feel free to remove those last couple of rows. That's just gonna confuse the API. But I'm curious if we were now to, oh no, wait. So yeah. So that reading JSON I think is also fine. But import polars as PL. Could you undo a few times? Because what I'm curious about is if you already have a good block of pandas code, but then you change, yeah. So just the import line. Let's just change that.
Yep.
See what it can.
Doesn't look like it wanted to make any edits yet. So this is also a good behavior that we want from models, is not to be spitting out stuff when it shouldn't be. So it's like a good balance of like, if you don't know, don't respond. If you do know, try to predict the next edits. And you'll see with the data that we've prepped so far, we haven't quite gotten to the point where we're like crawling the polars library or examples of that. I think that'll come in the next steps. But yeah, these are great things to kind of like test end to end so that you can see before you prep all the data, what data we need to collect next.
I had a question about additional context, but if you're going to get to that later, I can hold that question.
No, let's fire it in now. Yeah.
So yeah, I was curious if like in the training set, I think there was some plans you mentioned earlier about like adding some additional context, and I was curious, like the ones that come to mind are like, and I think Cursor may do this, like what's on your clipboard, so something that you pasted from somewhere else.
Yep.
But then also like if you have a mix of polars and pandas code, I think what Vincent was like alluding to is like what direction are you going? Are you converting it to polars or are you converting it to pandas? And I think giving the snapshot is one thing, but also giving like what the last edit was.
Yep.
And so someone's giving like a direction to where that snapshot was going.
Yeah. So a couple things we were thinking with this format, and Daniel, I think you're on the call too, if you want to add any more context with what we're planning to do here, but is have another block here and make this kind of extensible to the types of things that the model can learn to use. So actually one of the very first ones that we did, we tried to populate the diff of like the previous edit here. We just didn't have enough data for that yet. So we ended up shooting ourselves in the foot with a couple first fine tunes because we made it a little too complex. So started a little simpler, just make sure we can do this part. And then once the model learns that, we're going to start adding in additional tokens and additional blocks where we can put in things like your clipboard, the last edit you made, and stuff like that.
Hey, Greg. Just curious. I didn't see the model that was your starting point. Is it already Instruct tuned?
Yes. Yeah, it is.
Okay. So that I guess I'm curious about that. I mean, that explains the prompt format that you're using, but typically what I've seen for tab completion models is kind of like a continuation of pre-training just on code. So the quote unquote fine tuning of it is just the fill in the middle objective. So like a lot of times you'll see FIM start and FIM end, and then the cursor position is determined by that. And so it's just doing next token prediction like it's used to, but it's not a typical Instruct fine tuning.
Yeah, definitely. And we grabbed some of those fill in the middle data sets to populate our data set. I think the other things we wanted to add were like this intent block and then being able to extend it with other blocks.
Got it.
So I think that's like a great source of, we could do the continued pre-training as a first step and then do more Instruct tuning, kind of playing with all of those variations right now.
Okay.
Cool.
So I guess like more of a, if you're going to come to this later, like we can discuss about it then, but like what data how did you collect the data to fine tune this?
Yeah, we are going to dive into the data sets next. So
good segue.
Hold on to your horses. Here we go. And like I said, I like to cowboy it sometimes and just like collect the training data set without really thinking about the evals because it's pretty exciting to just get to the fine tuning. But every time I do that, I'm like, man, I wish I prepared an evaluation data set first because you can do all the vibe testing and prompting in a chat window, but without like an actual number to hill climb on, it gets hard to know whether these changes actually made a significant difference or not. So we started with this Google Research MBPP dataset as our evaluation. And if you're not familiar with this dataset, it consists of a bunch of text snippets or prompts, code, and the unit tests that need to pass for this code to be correct. So let's look at a easier one. Like this is a sort matrix function, and it has all the sorted matrices in the unit tests. This is like find the volume in a triangular prism, which I had no idea the formula for that off the top of my head, but we have that in here, and we have a couple test cases. So this gives us a good eval set of we know all this code at least passes. Now let's take it and let's corrupt it with user cursor is here. And we'll take a look at some of these. So we have the original prompt, the original code, and what we've done to create our eval set is randomly put the cursor is here within this snippet and see if the model can complete, put the user cursor at the end or at the proper place. Sometimes we do corrupt just like these two lines and put cursor is it here, and have the model try to fill in the middle there. And then make sure that it passes the unit test.
One really weird question, I suppose, about this data set, but I can't help but notice that functions here start with word underscore and then another word with a capital letter. Is there a reason for it?
This is a great observation. I don't know if there's a reason for that specifically, but what I did find is when I ran a couple of the state-of-the-art models out there on this data set, they nailed it. So I had all of the corruptions in there. I removed, everything after the cursor and had the model predict what should come next. Claude Force on it got 100%, and Llama 4 Scout got 97%, which always makes me a little skeptical that it just memorized this data, especially to your point of those were like some funky looking function signatures.
I'd be really curious if you were to sort of put the cursor on the function name, if it would also put the capitalization in there in this case.
Well, that's what it did. And so we looked a little deeper at the inputs and outputs, and it actually had just memorized the data. So I was like, okay, great. This isn't like the best eval set because clearly this has leaked into some of the pre-training data. So what I did was I had an LLM rewrite all of the functions and variable names so that it's a little more sensical for one. And this is just data that it probably hasn't seen before because it's been corrupted. So I did one pass on just rewriting the function names and variable names. And then I also ran all the unit tests again to verify that the LLM didn't hallucinate in that step. And after I did that, I think you guys will find this entertaining. Claude dropped 18% and Llama 4 Scout dropped almost 30% on that eval set. So that clearly tells me these models had seen that MBPP during their pre-training. And also
beautiful.
Gives me a little more confidence in the eval here.
Greg, that was I was just thinking the other day that would be a great use for was it small agents where Hugging Face released like they had a summarizer model and like a rephrasing model or something like that. Evals would be a great use case for that.
Yeah, I almost feel like you have to do this step before using any eval these days because like I don't know, they're just scooping up anything they can on the internet. And to be fair to the labs, like they can't check everything that's in the pre-training data. So if it's publicly out there, it's probably been trained on. You might as well do a little bit of corruption on it. Make sure it's still good data and then use that as our eval. Cool. So that's that half. That's the kind of hill that we'll be climbing. And then these are just good numbers to keep in mind of, Claude Force on it gets around 82% on this benchmark. Llama 4 Scout, 68. We're going to be training 1 billion and 3 billion parameter models. So if we can get up to these numbers, that's going to be really impressive. So just keep these numbers kind of in the back of your mind as we're going through. So now to the training data part. There's no lack of code out there for us to collect a training data set. The main question is like, how do we get a realistically looking training set with realistic edits? So for the MVP, we already had this function that could take in a code snippet and corrupt it, right? So this is actually just MBPP before the transform and MBPP after. So you guys can get a better sense of like, yes, we still have a calculate volume function, but now instead of L, B, and H, we have length, breadth, and height. And this is the new version that we'll be optimizing for. But as we wrote the eval dataset, we also wrote a function to like randomly place a cursor and then chop off some of the text and then place the cursor at a new location. So just to like keep it simple, we were like, what if we just ran that same function over a bunch of code? So grab a bunch of code snippets, run this function, delete the middle, and put the cursor in both places. So that's kind of what we started with. And we ran that on 3 different data sets. So I'll pull this. Oops, that's not the right one. We want the training data. Okay. So there's this nice Python code. Ooh, that's a good boy. Let's look at a smaller one. Python code instructions 18K alpaca, which had the nice property of having all of the prompts in there. So if you remember, we had this kind of intent block that we wanted the model to print out before it started making its edits. We kind of reversed the task, where the task in Python code instructions 18K alpaca was to go from this to here. So we took those 2 things, made that the output, and then the input is no intent, our system prompt, and then a corrupted version of it where we have user cursor is here. So I'll pause there for any questions, but it was kind of just taking this existing prompt code data set, corrupting it to create the input, and then we already have the ground truth as the output. So we did that for both this, what was it called? Python code instructions 18K alpaca and the MBPP training data set. And we also did it with Marimo's code base itself. This one was a little more interesting, where we crawled all the pull requests and we looked at the code in the diffs, and we grabbed that code snippet, corrupted a bit of it, and then put the comment from the PR right in here as the intent for these changes. So this at least got us a little more Python code in here, and hoping that it helps the model understand Marimo itself. I think we can do similar things on Pandas, Polars, all these other libraries, but we wanted to at least get some library code in and not just limit it to these Python code and MBPP training data sets. So this was kind of our MVP. Let's kick off a train on 18,000 examples that have, you know, a system prompt, an empty intent, a code snippet, cursor is here, and then it should be able to fill in everything beyond that and place the cursor at the end of that snippet. Any questions there? It's a pretty simple data set, pretty simple corruption, but this was our starting point.
I just have a question out of curiosity, because I can imagine, okay, you've got a good a code base, you've got the commit messages, like that's kind of useful. You can wrangle some data set with that. But I can't help but wonder, like the Marimo internals are probably going to be different than the code the average person would write inside of a notebook itself, right? So like,
Yes.
is there maybe like not a concern there as well?
Yeah, that's a good question. We were thinking about this even in the context of Polars and Pandas as well. So Daniel, are you on the call? Because I know you've been doing most of the heavy lifting here. If not, that's cool. I can.
I mean, I can definitely see the, like, I'd definitely be curious what the results are if you do it on or off, right? Like that doesn't necessarily feel like a very bad idea, but does feel like there's a concern though. Like that's the only thing I feel when I look at this.
Totally. And so what I was going to allude to there is like finding the examples repository is another great place to look for this data. So the actual usage of the library. But I agree. I think in general, we're leaning towards more data is going to be better. So even including the internals, you know, we're hoping to scale this data set to hundreds of thousands, if not millions of rows.
The main concern right now is data set is small. So like fixing that first, and then we can worry about like other details later. Fair enough.
Exactly. So we've been iterating on this data set. Daniel's actually got another iteration that we can talk about at the end, where we're looking at the actual abstract syntax tree of the code itself, trying to rename variables, trying to rename functions, and then seeing how that cascades as the next piece of edits. And quote from Daniel as he was going through this, we're like, abstract syntax tree makes a lot of sense. And so he started taking a stab at it and realized that the library he was using actually makes you lose a lot of the original formatting when you're just looking at the abstract syntax tree, which one, makes the code less diverse if you just like reconstruct it from there. And two, you actually don't really know where the modification is happening. So he switched to using a concrete syntax tree, which holds a little bit of the formatting. Unfortunately, that's not great at handling code with syntax errors. So he was chunking everything from these libraries. And like, if you're missing, some part of the code above, or you're missing some of the import statements or the libraries, that messes things up too. So we were like, oh yeah, abstract syntax tree is going to be so easy. We just like take a bunch of code and augment it using that. This is where like a lot of the work is going to go in collecting this data set, is making these pipelines and making sure that you don't just make the task too easy, and that it's actually valid code that we're putting together. So from here, we actually have, if you have a data set within Oxen, it gets superpowers. And one of those is being able to fine tune a model on top of it. So this is all we did for fine tuning. Right now we support the small Llama models and the small Qwen models. You kind of just pick your input source, pick your output source, and start a fine tune. Once that fine tune is done, we then can deploy that model to an inference endpoint for you. We link it back to the exact version of the training data set that went in, and give you like a chat completions API, which is what we were interfacing with here. So the fine tuning half of this was actually the easiest half. It was just clicking a couple buttons and running a bunch of experiments. And so we did that with a bunch of models, and here are the results that we have so far. So obviously not all of these models in this list were fine-tuned. Anything with a funky name that we generated are the ones that we fine-tuned. But we wanted to benchmark, like we said, against Claude 4. We threw in Qwen 3 Coder and Kimi 2 in the process because they're hot new models. Llama 4 Maverick, GPT series. And then here you can see Qwen 3 starts batting above its weight. So on that simple 18K example training data set, we actually got Qwen 3 4B to get all the way up to 68%. And if you remember that number from earlier, Llama 4 Scout out of the gate is also 68%. So we're starting to get into the realm of like 100 billion parameter models with a 4 billion parameter model, which is super encouraging, just from those minimal edits. Qwen 3 1.7B also gets above 61%. And then the Llama suite of models, still working on optimizing, but they're hanging around 50%, or the very small 1 billion is 38%. And we've actually been doing most of the iteration with Llama 3.2 1B, because if we can teach this thing, which seems to be the worst performing thing, every time we've made an improvement here and used that same training data set on these ones, accuracy just goes up. So we're kind of just teaching the dumbest model over and over again, and then applying that same data set and getting a big boost in these bigger models, or models like Qwen, which candidly were trained on more coding data in their pre-training step. Llama didn't explicitly train on as much coding data as Qwen did. Any questions here? Thoughts? I think it's
just out of curiosity, like It's nice to have like a button and it kind of hides away lots of the hyperparameters, but I'm assuming you probably have fiddled around there a little bit. Like any lessons from that part of the journey?
Yeah, we do have, let's look at this a little deeper. We do have some advanced, settings within
Okay.
here if you want to. We just want to make it as easy as possible just to like kick that off
Oh,
without
sure,
thinking too much
but
about
those are
it.
like sensible defaults that you found, like because you're only training for one epoch or something. I'm seeing here, for
Yep,
example. But like,
yep.
these are just numbers. You tried them and they seem to work, or is there like a book you got them from, or?
No, these were the ones that kind of came by default with the Hugging
Okay.
Face Transformers library.
Fair enough.
And honestly, we haven't done too much exploration of these. They seem to work pretty good out of the gate. I know, Daniel, you had some experience using this Neft tune that helps the model generalize a little more. And then sequence length has also been a thing that we've been tweaking a good amount, and especially to Miles' point of, how are we going to include more context? Sequence length really determines how much GPU power we need behind the scenes, because if you have a longer sequence length, you need more memory to train. So that's kind of one of the things that we've been doing behind the scenes, is making sure that we have the right GPU infrastructure to kick off and train these models, given the hyperparameters that you've put here. So unfortunately, no huge learnings for you, Vincent, but
No,
we
it's fine.
have
But
the,
it's like I think it's perfectly fine to say, well, we don't have a best practice, but we try to have sensible defaults. Like that's a totally valid way
yep,
to go about it. But I always like to ask because sometimes there's like a good lesson.
yeah, totally. Any other questions from the squad?
Daniel did also mention that Llama pre-training doesn't include FIM, unlike Qwen.
Right. Yeah. So when we say FIM, that's fill in the middle. So these Qwen models were pre-trained on the task itself, so that gives us a hint to why they're performing better. Fun fact: we are working with the Llama team themselves on the next iteration of them to have more fill in the middle data, but stay tuned for that. So even though Llama's at the bottom here, we have whispers that it won't be in a bit.
Hint, 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 hint.
Hint, hint. Cool. So that's pretty much where we got so far. You guys kind of saw it running live in that editor. Definitely isn't perfect yet, but starting to work. And I think wiring these things up end to end kind of shows you where the holes are, where you need to add more evals to. And we've got this end to end pipeline set up. So the next thing is scaling up the training data collection, doing those abstract syntax tree or concrete syntax tree transformations. And we kind of just want to get V1 out with those modifications to let people start using it, give us feedback. As we're collecting feedback, we can start to build out our reinforcement learning pipeline. If you've joined some of the dives in the past, we've done GRPO with verifiable rewards on Rust code, specifically having it learn to pass unit tests, learn to pass the linter, learn to pass the formatter. And Marimo actually has, or Marimo, sorry, I feel like I keep saying it wrong. It's Marimo, yeah. Marimo.
That's how we say it. It's technically a Japanese word, so.
That's fair. Marimo does have, the variable dependency parser that Vincent showed at the beginning. So I think there are verifiable rewards that are specific to this editor that we can encode into the model, which is pretty exciting. And then the other thing that's exciting is as people are, hitting tab accept or continuing to type, or maybe they explicitly reject, that actually helps you create a direct preference optimization data set from human feedback. So we'll be collecting that internally, at least as we're iterating on the model. I think it would be really cool to have it be a community effort where optionally you could log your exceptions and rejections and build a really big DPO data set on top of that. But these are the types of experiments we'll be doing before we release V2, but want to get something out there, let the community play with it. And yeah, working tightly with the Marimo team and the Llama team to make this happen. So with that, I will kill the recording. Thanks for watching if you're on YouTube, and we'll just have like 10 minutes of just random discussion if people were too shy to be on camera or just want to talk about things that we can't have on the recording. So thanks, y'all. Thanks for joining.